Hello everyone, I am Nandini, Department of Computer Science Engineering Artificial Intelligence from Sri Venkateswara College of Engineering, Bangalore. Today we are going to discuss about quicksort and its time complexity. Let us know what is quicksort. Quicksort is a sorting algorithm based on the divide and conquer algorithm that picks an element as a pivot and partitions the given array around the picked pivot by placing the pivot in its correct position in the sorted array. Quicksort is one of the famous sorting algorithm. It sorts the given data items in ascending order. It uses the idea of divide and conquer approach. It follows the recursive algorithm. Next is how does quicksort works. Let us see how it works. Quicksort works by partitioning the array to be sorted. Each partition is internally sorted recursively. As a first step, this algorithm chooses one element of array as a pivot or a key element. The array is then partitioned on either side of the pivot. Elements are moved so that those greater than the pivot are shifted to its right, whereas lesser than the pivot are shifted to its left. Two pointers low and up are initialized to the lower and upper bounds of the subarray. Up counter will be decremented and low counter will be incremented as per the condition. This is the algorithm for quicksort. Quicksort of array a, start, end. If start is lesser than end, p is equals to partition of a, start, end. Quicksort of a, start, p minus 1. Quicksort of a, p plus 1, end. When we come to the partition algorithm, partition of array a, start, end. Pivot is a of end. I is start minus 1. For j start to end minus 1. Do if a of j is lesser than pivot, then I is I plus 1. Swap a of I with a of j. Swap a of I plus 1 with a of end. Return I plus 1. Using pivot algorithm recursively, we end up with smaller possible partitions. Each partition is then processed for quicksort. Partition algorithm, the logic is very simple. We start from the leftmost element and keep the track of the index of smaller or equal elements as I. While transversing, if we find a smaller element, we swap the current element with array of I, otherwise we ignore the current element. Here is a simple example of quicksort. Here we took an array consisting of the elements 19, 17, 15, 12, 16, 18, 4, 11, 13. As per the condition, we have to select the pivot element. We can select first element as a pivot element, or middle element as a pivot element, or a last element as a pivot element. Here we selected 13 as a pivot element, which is at the last, and we have to sort this array into two sub arrays. We have two conditions like less than or equal to 13 and greater than or equal to 13. The smaller elements should be the left of the pivot element and greater element should be the right side of the pivot element. The left side elements are 7, 12, 4, 11. The greater elements are 18, 15, 19 and 16. Again we have to sort this array. We selected 11 as a pivot element. The same conditions will apply here. Less than or equal to 11 and greater than or equal to 11. Less than or equal to 11 elements are 7 and 4. Greater than or equal to 11 is 12. Again we have to sort. We selected 4 as a pivot element and 7 is greater than the 4, so we have returned to the right side of the pivot element. When we come to the right subarray, the elements are 18, 15, 19 and 16. Here also the same conditions like less than or equal to 16 and greater than or equal to 16. Left side of the pivot element is 15 and right side to the pivot element is 19 and 18, and we selected the next we selected the 18 as a pivot element. 19 is greater than 18, so we return to the right side of the pivot element. Next is the time complexity of quicksort. In time complexity, we have three cases like best case, average case, and worst case. When we come to the best case complexity, in quicksort, the best case occurs when the pivot element is middle element or near to the middle element. The best case time complexity of quicksort is big O of n log n. When we come to the average case complexity, it occurs when the array elements are in jumbled order, that is not properly ascending and not properly descending. The average case time complexity of quicksort is big O of n log n. Worst case complexity. In quicksort, worst case occurs when the pivot element is either greater or smallest element. Suppose if the pivot element is always the last element of the array, the worst case would be occur when the given array is sorted already in ascending or descending order. The worst case time complexity of quicksort is big O of n square. These are the three cases of a time complexity of quicksort. These are the equations. Some of the advantages of quicksort are it is a divide and conquer algorithm that make it easier to solve problems. It is efficient on large data sets. It has a low overhead and it only requires a small amount of memory to function. It works rapidly and effectively. And it has disadvantages too. Some of the disadvantages of quicksort are it has a worst case time complexity of big of n square which occurs when the pivot is chosen poorly. It is not good choice for small data sets. It is not a stable sort, meaning that if two elements have the same key, their relative order will not be preserved in the sorted output in case of quicksort, because here we are swapping the elements according to the pivot's position without considering their original positions. It is unstable. The variants of quicksort are multi-pivot quicksort, external quicksort, three-way radix quicksort, quick radix sort, block quicksort, partial and incremental quicksort. Real-time applications of quicksort. There are many real-time applications. We can see some of them. File systems. To organize files and speed up file access and retrieval, quicksort is utilized. Quicksort is used in database management systems to sort huge datasets for better data search and retrieval. Operating systems. Sorting and managing processes, tasks, and applications are done in operating systems via quicksort. Objects, images, and animations can be sorted and arranged in real time using quicksort in the development of graphics and video games. Next is compiler design. Quicksort is used in compiler design for sorting and arranging symbols, tokens, and identifiers. At last, we come to the conclusion that quicksort method sorts the element using the divide and conquer approach. It has an average of big O of n log n complexity. It can be implemented in both recursive and iterative ways. Quicksort is in space, cache friendly, and also tiled recursive algorithm. Divide the array into smaller subarrays until there is only one element present in the array and sort the array recursively. Thank you for watching.